At Bentley, we're really excited about the convergence of geospatial, and all the speakers that spoke this morning talked about an inflection point of this technology. And what I'm going to share with you for the next 20 minutes or so is how the geospatial context applies to infrastructure solutions. And at Bentley, we define infrastructure as the interface between people and the planet. And as all of you probably know, the higher the quality of the infrastructure, the better the quality of life for all of us. Clearly, every piece of infrastructure exists somewhere on the planet. So therefore, the geospatial context is intrinsic to every piece of infrastructure. Now, at Bentley, we provide solutions for all types of infrastructure, from onshore to offshore, and we've been at it for the last 30 years. Now, whether you're building something new or you're extending something that already exists, you need to capture the existing reality. If something doesn't exist before, you need to capture the ground reality, the site conditions. If something already exists, you need to capture its as-built condition. So we use the term reality modeling to capture that information of the as-built environment or the as-existing environment, and it's essential reference to design, to construct, and then operate the infrastructure. Now, traditionally, this has been survey, which has taken a long time and slow, and what I'll share with you is some of the new advancements in the area of reality modeling. Clearly, you'll find, if you go over to the exhibition booth, you can capture reality today by various means. Professional devices, the session's about commoditization, so now you can think of consumer devices that are helping us capture this reality. So I'll just share with you some of the technologies that are becoming mainstream in this process. You'll see laser scanning, which has been there for a while now, which is allowing you to take and capture billions of points in hours. Moving on to these big devices and shrinking them down to now handheld laser scans, which are cheaper, lighter, faster. Moving beyond laser scans, you've got a game-changing technology with digital cameras, and I'll speak to this briefly in a few more slides on how cheap and effective digital photographs can be an integral part of reality modeling. And of course, drones, UAVs is fast becoming another quick way of capturing reality. Now, a speaker earlier this morning talked about, I think it was Secretary Sharma, talked about 900 million mobile phones. Imagine if every smartphone was a capturing device for you wherever you went, and you could use the data you captured from your phone to help you with your geospatial context for infrastructure. Now, all of these techniques can apply to every type of infrastructure, from large industrial plants to transportation environments, extending across all these different types of industries. They're applicable, as I said, from civil engineering to mining to transportation to oil and gas. There are other sensors as well, because a large part of the built environment actually exists subsurface. So you have ground-penetrating radar as other types of sensors. You saw Chris this morning talk about these scanning devices that you can put onto mobile vehicles, and also video cameras. Now, when we talk about capturing all this reality, one of the big challenges we have is when you take all this voluminous data, what do you do with it? How do you share it? How do you process it? How do you make it something consumable so that all the engineers and architects and operators can do effective things with that information? And that is, again, lots of new technology that I can share with you that is the convergence of cloud computing, desktop computing, cheap storage is making all of these things possible, which is, again, speaking to the topic of the session, which is commoditization. So basically, the geospatial context And again, we spoke this morning about Digital India. There's a convergence of the physical environment with the digital environment. And that convergence is what is so unique, and that is the inflection point for all of us that has us all really, really excited to be part of a solution provider for the infrastructure solutions industry that we are. Again, I think Secretary Sharma talked about the importance of standards. We at Bentley firmly believe that standards are really important for all of you because you're working with solutions from various vendors, us and other people. So we absolutely are working closely with the OGC. I think the OGC is here as well in moving forward and advancing standards so that all of us can essentially interoperate because the infrastructure deficit, there isn't enough money to build everything we need to build on our planet. So the last thing you want to be doing is wasting money on translating between formats instead of spending your time leveraging everything. So that's why I think open standards is really, really an important part of our philosophy. So what could you possibly do? So I have some interesting AVIs. So this is an example of being able to take some of this fascinating technology and apply it to a real project. Let's say you have an oil and gas plant, and you need to replace one of those vessels to extend the life of the plant by another 10 years. And removing that vessel requires you to be able to, if you didn't have all of this technology, you would probably take 5 times as much time to do it as opposed to being able to capture the digital model, figure out what type of a truck can actually get there, figure out all the different ways of extracting it, all the different obstacles you'll meet along the way. So you can actually model that exact set of activities digitally before you actually go and get that done physically. Right? So that's a perfect example of a geospatial-enabled solution that can unlock huge productivity for all of us in our industry. So it helps us make better decisions. As I mentioned, every piece of infrastructure exists somewhere on the planet. To do any kind of work, you've got to get information from so many different sources: satellites, images, models, different disciplines. You've got, in any complex project, hundreds of engineers working across different offices capturing data. And if you thought about the amount of time they have to spend coordinating all the geometry, the geography, the coordinates, the lat long, it's a lot of time that gets wasted, which you could almost say that intrinsically geo-coordination is a huge value proposition of our solutions when you think about the geospatial context. So essentially, you can imagine in our lifetime, digital or virtual construction sites that might look something like this, where you've got the convergence of video, images, and physical cameras, allowing you to sit anywhere in the world and see exactly what is happening at your construction site. So I'd like to proudly announce a new acquisition that Bentley Systems has done that I think is reflecting the commoditization theme of this conference of being able to take just plain photographs and convert those photographs really easily to 3D models that we can use as reference. So just about a week or two ago, we acquired this company in France called Acute 3D. And I'll just show you briefly that technology. So basically, this is software, and you can see it in our booth, that will help you take and convert photographs into 3D automatically using a concept called reality meshes. This will work across scales, so you can take photographs for 3D buildings, photographs for cities, street work, and all types of infrastructure, from refineries to oil and gas plants to roads, to utilities. And there's some of these case studies that you'll find that are being spoken to of the kinds of things that have been done with this technology, where in this case it was 500 square kilometers of Stockholm City, and they created a georeference model just with photographs. And it was used as a decision-making tool. Think about smart cities that we want to do in India and the application and the applicability of such fabulous technology. buildings, historic buildings. This was also used in Japan during the moments of natural disaster. So you can go in after natural disaster, take photographs of the region, and of course, you could do that with laser scans as well, but digital photographs, the cost is cheaper, the processing is faster, so you're able to get and react and make better decisions much faster. This is being used even by retail stores because a lot of the factories that they've built don't have physical models, used underground, subsurface. Now, traditionally, in the past, our computers haven't been strong enough to be able to model reality. So you've had to make real simplifying assumptions, and that's been limiting for us. So if you look at an intersection, a real-world intersection, a traffic intersection like this with lots of flyovers, and you want to use this as a basis to build an asset management system for transportation, you might take a traditional GIS system and simplify things because that's all you could possibly do. That was the capability of that system. You had to idealize things into single lines, right, on a reference, and that was your GIS. And then when you try to build an asset management system on it, it really doesn't have the capabilities you need because if you think about it, an asset management, transportation asset management has to deal with road degradation. One of the outside lanes may degrade at a different velocity than the inside lanes because the amount of traffic is different. So really you need a digital model that reflects the physical reality to really build an asset management system beyond using simplifications that some of these older systems have made you do. And I'll speak to that now with some specific use cases in transportation asset management of real-world examples of this being used. Now, a traditional asset management system really starts with capturing existing reality with a reference model, going all the way up to helping you make decisions about how do you want to invest your limited amount of capital, which sections of road really need fixing, which sections of road you can wait, defer on, where the potholes are, do cross-asset optimization across all the different types of bridges, drainage structures that you might have in your asset management system. So a specific example I'd like to speak to is the highways agency, Highways England. So they have over 7,000 kilometers of national highway. They have over almost 10,000 bridges. You can see all the statistics on this slide. I won't speak to it. Their total current value of their strategic road network is over 100 billion pounds. This is being managed today across 17 different systems. They're converging all of this into one asset management system. They expect to save over 2.5 billion pounds over the next 10 years. So in order to do this, they need something that's rich enough to capture all the different types of reality of what they have. Build an asset intelligence, a performance network, such that they can make the kinds of decisions I was talking about. So it's going to go from replacing, as I mentioned, 17 agencies and supply systems into one national asset information management system that goes all the way from pavement to drainage to their structures, which means bridges and culverts, et cetera. And it's all based on this geotechnical reality model that I was talking about. And not just in the UK, but even in India, a metro project that's near and dear to all our hearts locally here, the Hyderabad Metro, which is being under construction, is actually the largest public-private partnership in the world, from what I understand. It's the first phase alone has 3 corridors, around 70 kilometers. And there are various products that you can use that captures all of the reality in 3D with a level of engineering detail that you can use from design through construction and then over the decades that you need to operate this asset. Again, there are other projects across India that people are using, from using the Vasai Virar City Municipal Corporation, using, I think a person earlier today talked about big data The amount of data that's being captured because you can is exploding. And being able to process this big data, you can see that the decisions you'll make will be richer, more effective, and you get a faster return on investment, as in this project. Within 6 months, they were able to extract an ROI. In this particular case, this $3.5 billion project is around 1,500 square kilometers, which is the Delhi Jal Board. Again, capturing their existing reality of their water modeling network. Feasibility studies. When you are, again, operating on a constrained environment, when you have a limited amount of budget, what do you want to do? What's the best investment decisions you can do and get the best benefit to all of us that are consuming this infrastructure? Here's an example of doing a feasibility study by NHAI. The Odisha government is using this technology to manage their 14,000 kilometer state network using an asset management system for their roadway assets. So this is the kind of things that you can imagine. So this is an example of the technology that's capable because of the consumerization and the commoditization. You're seeing real time on this video the entire city of Paris converted into a 3D model with 140,000 photographs. And going from those photographs to the mesh is automatically done without any human intervention. Think about what sort of a smart city infrastructure you could have that you could build from with information available to you at the precision that you can measure from. In this case, it's moved on to imagine that you had to re-electrify or extend a rail freight corridor network. You had to go and scan and fly over everything that existed and then use that as a basis to re-electrify it, to convert it to high speed, and all the automated way that you can go from that data of photographs to then the meshes and then to the model and then be able to effectively use it in your workflows. So we are really, really excited about all of the availability of the consumerization of the hardware, the availability of cloud computing, bringing together mobile phones and apps such that all of us in the infrastructure business can be far more productive over the next decade than we were in our prior decade. So with that, I welcome you to come and check out some of our technology at our booth. I thank you guys very much for this session and hope to see you next door.